Hey guys, welcome to Math for Kids by Kid. Today we're going to talk about mixed and entire radicals. These are all examples of entire radicals. So in a radical there are two parts. There's the radicand, which is the number underneath the radical sign. And then there's the little number to the left of the radical sign, which is the index. And the index is referring to the root of the radicand. So in this example, you have 32 to the fifth root. So this radical represents the number that multiplies itself 5 times to get to 32. And these are examples of mixed radicals. So one thing you'll notice that's different about these than the entire radicals is that they have a number in front of the radical, like the ones I've circled. And these are coefficients. Mixed radicals represent entire radicals, and entire radicals represent mixed radicals. You're probably wondering, well, why do we need to write an entire radical as a mixed radical? Well, that's because if you're asked to solve a radical and you can't get a whole number as a result, then you must write it as a mixed radical. So I'll show you what I mean. Let's say you are to solve this, the square root of 72. 72 is a non-perfect square, so this is irrational. And you will obviously not get a whole number as a result. And so if you're asked to solve this, then you can simplify it by writing it as a mixed radical with a coefficient multiplied by a radical. In order to express an entire radical as a mixed radical, you need to create a factor tree of the radicand to find all the factors of the radicand. So here, 72 is 2 times 36, and then 2 is a prime number, so we don't need to factor it anymore. 36, 6 times 6, and then on each 6, 3 times 2, and 3 times 2. So these are the prime factors of 72. And now from these prime factors, we're going to figure out which factors of 72 are perfect squares. So we need to find pairs of like numbers. So looking at our prime factors, we have 3 2s and 2 3s. So I'll just write it out. 3 2s and 2 3s. We have a pair of 2s and a pair of 3s. And since we know that a perfect square can be square rooted and then two numbers can multiply to get that number, we know that all we need to do is find a pair of numbers to find the perfect square factors of 72. So these pairs of 2 equal 4, and the pairs of 3 multiplied together equal 9. And so we're going to multiply 4 by 9, which is 36. And then we have a 2 left over, so that's 36 times 2. So what this is saying is that the square root of 72 is equivalent to the square root of 36 times 2. And from here, we know that 36 is a perfect square, so we can go ahead and simplify that to 6. And then we can square this 2 here. And this is how you express the square root of 72 as a mixed radical. Let's do another example here, except we're going to cube root a radicand. So let's say we need to solve the cube root of 40. Again, this is not a rational number, and 40 is not a perfect cube, so we have to express this as a mixed radical. So like before, we're going to make a factor tree of 40 and find all the prime factors. So 40 equals 2 times 20, 20 equals 10 times 2, and 10 equals 5 times 2. And these are the prime factors of 40. Now the only difference here is that we're going to find the factors of 40 that are perfect cubes, not perfect squares, because in this case, unlike the other one, we're cube rooting 40, not squaring it. So here we have 3 2's and 1 5. So in this case, we need to find 3 of the same numbers repeated. So here we can see that 2 is repeated 3 times, and 2 times 2 times 2 equals 8. And then we have this 5 left over, so that's 8 times 5. And so 40 cubed is equal to 8 times 5, the cube root of 8 times 5. And from here we know 8 is a perfect cube, so we can go ahead and solve that and write 2, and then cube root 5. And this is the final answer. Now there's some entire radicals that you cannot express as mixed radicals because the factors of the radicand are not perfect squares or perfect cubes or whatever depending on the index. So like this example. The square root of 35. If we draw the factor tree of 35, we get only 5 and 7. These are both prime. No factors of 35 are perfect squares. So you can't write this as a mixed radical. Now I showed you how to write the square root of 72 as a mixed radical, and now I want to show you something slightly different. If we have a negative in front of the radical, the answer will be the exact same, except there will just be a negative sign in front of the coefficient. So there'll be negative 6 times the square root of 2 instead of just 6 times the square root of 2. Now, if the negative was included inside the radical, then you cannot solve this because you cannot square root a negative number. And this applies for all radicals with even indexes. So even if this was negative 72 to the 4th root or negative 72 to the 6th root, you cannot solve it because the negative is contained inside the radical, so you can't write it as a mixed radical. For the example I showed you earlier about cube rooting 40, you could solve it if the negative was contained outside the radical like this, or if the negative sign was included inside the radical like this. And the reason why you can solve it both ways is because you can cube root a negative number. This applies for all radicals with odd indexes. So you could solve this or this. The only difference will be that for the answer, the coefficient multiplying the radical has to have a negative in front of it. Now let's do the complete opposite. Let's look at how to express mixed radicals as entire radicals. So let's look at this example. 5 times the square root of 10. We need to move this 5 so that it can go underneath the radical sign. So what we're going to do is, we're going to take the square root of 10 and multiply it by 5 to the power of 2, because in this case it's a cubed root, and the opposite of that is squaring a number. So we're going to solve from here. This is 10 times 25, and from here 10 times 25 is 250. And this is how you express 5 times the square root of 10 as an entire radical. Now let's look at this example. 2 times the fourth root of 2. So again, we're going to move the 2 so that it goes underneath the radical sign. Except this time, it's going to be the fourth root of 2 times 2 to the power of 4, because it's a fourth root here, and the opposite of that is raising a number to the exponent of 4. And so from here, we're going to solve. The fourth root of 2 times 16, which is the fourth root of 32. And this is the final answer. Now let's say we were to solve this, but it was negative 2 times the fourth root of 2 instead of positive 2 times the fourth root of 2. The answer would be exactly the same, except we just put a negative in front of it. So it would be the fourth root of 32, and we just put a negative in front. So basically, the steps are the exact same, except we're just moving the 2 over and leaving the negative outside till the very end here. Now if we had negative 2 times the cube root of 2, this time we could technically move the entire negative 2 underneath and put it under the radical sign, or you could just put the 2 underneath and leave the negative outside, because either way you can cube root a negative number. Now let's do it, but we're just moving the 2 over, so both these ways are correct. Thanks for watching, guys. I'll see you soon.